So hello everybody, we are Marie-Pierre, Oudot and Benoît Lelandais from CEA and Laurent Delaigue from Obeo, and we are going to present our experiences on integrating Xtext, Sirius and EMF Compare to design simulators of complex physical phenomena. So we are part of the French Alternative Energies and Atomic Energy Commission. It is a major player in high-performance computing thanks to the simulation program. This program is divided into two parts. A hardware part in collaboration with Atos Bull to design future generation of calculators, and a software part in order to get the most predictive simulation codes as possible and to make the most of high computing power. This program leads to a new generation of HPC computer every 5 years, whereas simulator life cycle is around 20 years. Consequently, it's very difficult to upgrade our codes so frequently to take advantage of the computing power. This is the reason why we have to abstract domain knowledge from technical knowledge. So our job as software engineers is to propose and develop new tools to handle abstraction and help developers with the technical part. Before going further, we just have to precise that our developers are mathematicians. They design numerical schemes, they code them, usually in C++, and after they validate them on physical cases. So we are going to present the technical context. Since year 2000, our simulators are based on the Arcan framework. Arcan is a C++ framework for three-dimensional parallel codes. It handles, for instance, mesh variables, memory, load balancing, parallelism, input, outputs, all services needed by simulators. Today, several big simulators are based on Arcan, and we have introduced the use of UML during their requirement process. The use of Arcan and UML allowed us to capture the domain knowledge and to improve the design of simulators. UML diagrams offer us great support for brainstorming, increase the collaboration, the collaborative work between domain experts, and are used also to communicate and train newcomers. But we failed in keeping the model synchronized with the source code. Day after day, source code evolves and grows, and the model is never updated. Consequently, after several months, the model does not represent the code anymore, and up-to-date information is lost in the middle of the C++. So after those experiences, our objectives were to keep the pros we have listed here, but during all along the life cycle of simulation codes. For this reason, we decided to develop Modane to graphically design the different parts of the architecture and to generate skeletons for the C++ code. Modane started in 2012. At this time, we wanted an Eclipse integrated guy because most of our mathematicians developed their C++ code within Eclipse. We evaluated GMF, Eugenia, and Graffiti, but we estimated that it would take too much time to develop such a guy. We hadn't heard about Sirius at that time. We then decided to customize Magic Draw with a dedicated profile. However, we haven't integrated the generation inside MagicDraw because we had a painful previous experience of using code generation with UML models. So we built a Modane dedicated EMF model. The MagicDraw model is exported. It is then transformed into the Modane model, and the C++ code is generated. All these transformations are done with the Xtext language. So this MagicDraw version is daily used by around 20 code developers. They complain about switching from MagicDraw to Eclipse to go from design to development. And they also complain about entering model details in a graphical way. For instance, for operation arguments. It represents too many mouse clicks for them. In addition to that, they had to divide the model into small parts to avoid conflicts that are tricky to solve on the complex UML meta model. So to bring an answer to these drawbacks, we recently started developing a fully integrated Eclipse version based on Sirius and Xtext. Sirius allows us to recover the current graphical functionalities, and Xtext allows us to fill some model parts without mouse clicks. Concerning collaborative work, we are currently working on EMF Compare, as we will see later. So we have finished with the introduction, and we will now focus on the description of the Modane application, and Marie-Pierre will present.
So here you can see the main window of this new version of Modane. We will detail each part in the next slide, but what we can see is a nice Sirius diagram in the main view. Oh, sorry. And on the left, a project explorer to browse semantic elements. The Sirius diagram, it presents concepts for numerical simulation. For instance, we deal with module to describe physical components like hydrodynamic, or variable to describe physical quantity such as pressure or temperature. On the right, the palette enables to graphically create these elements, but they can also be dragged and dropped from the Project Explorer into existing diagrams. The components of the simulator are gathered in packages, and a specific color is applied to the element of a specific package on the diagram. Here you can see blue and green. And this can be customized by the users thanks to a properties file. Our end users wanted to get back some useful function they had in MagicDraw. So associations can be represented as roles or as properties depending on the choice of the user. Also, they can customize the presentation. For instance, they can choose to show or hide the properties block and show or hide the operation blocks. They can also, thanks to a contextual menu, display related elements or display children of a selected element. And they also can navigate through diagrams thanks to double-click. Thanks to Modane, we try to improve the quality of our design of our simulators. So therefore, some classical design errors we usually encounter on our code are prevented directly by the structure of the meta model. And the others are checked thanks to validation rules, and errors are shown on the diagram. And at the bottom, you can see a nice property views that is customized thanks to Sirius 4. The contextual explorer of the Amalgam project has been easily integrated in Modane. To dependencies between, when you click on the element in the diagram, you can see on the left part of this view the referencing element, and on the right part the referenced element, and it is very useful for our users. Concerning the variables such as temperature or pressure, as they are used by several modules, we chose not to present them on each diagram. We prefer the dedicated representation as a table because it is suitable for this kind of element with basic properties and single cardinality. We also have an Xtext editor. It offers completion and syntax coloring. The grammar has been well crafted with our end users in order to have a nice efficiency. And on the right, we have an outline that enables to browse the different elements of the model. And we have to say that the validation rules and the quick fixes are shared with a Sirius diagram. We will now talk about Sirius and Xtext integration, and I think that it will interest lots of us. We had some tricky setting to do to have a fine integration. The first one is relative to index of elements in collection. By default, in a collection, elements in EMF are referenced by their index in the collection. But in Xtext, every element is identified by a qualified name. So we had to post-process the eCore meta model that is automatically generated from the Xtext grammar to add a unique key to elements of collections. It is what we can see on the left part, the meta model and the e-keys. On the second point is about the organization of our models in the project. The project is a set of Sirius diagrams and Xtext files that are instances of Modane model and gathered into packages. And the path of the Modane model in the project define the path where the C++ code will be generated. And we have only one ARD route at the top of the project. We have used an advanced feature of fragmentation and defragmentation of this root ARD in case of changes in the organization of the model in the structure. And it was tricky. Another problem we have encountered is how to deal with the deletion of referenced element. For example, in the diagram, we can see if I suppress the equation of state interface, the Xtext model can be saved even if it contains an error on the reference between for instance, the service perfect gas and the equation. But on the other end, the Sirius diagram can't be saved until it remains inconsistent. To handle this question, we chose to delete all references when suppressing an element, and we have developed with Obeo a dialog box that informs the user of the impact of the deletion. And last point about Xtext and Sirius integration, we have a contextual menu on each editor on the diagram to open the corresponding Xtext file at the right offset. I will now talk about the integration of Modane in Eclipse. We wanted to offer our users a full integrated and nice environment. So we have enriched the Project Explorer with dedicated functions. For instance, the errors on the model are highlighted in the Project Explorer with specific markers. And we also developed some contextual menus to do action related to the organization of packages, as you can see on this screenshot. Once the model is complete and validated, the code generation can be launched from Eclipse. The generation options can be filled in the property window of the project. And only the skeletons of operation are generated, since Modane doesn't deal with the behavioral aspect of the code. So we generate skeleton for each operations, and then the mathematician can fill their C++ body in the same environment. And last point, we have a shortcut to open the C++ file corresponding to the selected model element in the editor when you are in Sirius diagram or in the Xtext editor. You can go to the C++ file. We have finished with the presentation of Modane, and we will now focus on collaborative work. And we have worked with Obeo to achieve this tricky point. So I will let Laurent Delaigue explain you the job he made.
Hello, thank you, Marie-Pierre. So hello, everybody. I will be talking about how we have collaborated with the CEA on this topic to address their concerns. I've tried to summarize all that through 3 examples that best illustrate how Sirius users can take advantage of the community and of Obeo to address their specific concerns, because as soon as you deal with a specific environment, a specific business, you will find out that the tools do not always cover all the use cases, and you need to address your specificities. So in the case of this Modane project, comparison and merging was done using EMF Compare. So as you know, when you start dealing with models and version control systems like Git, you have to use a tool to support comparison of different tools, and EMF Compare is a great tool for that. However, in the case of Modane, the EMF models used are heterogeneous. By that I mean that they used both graphical syntaxes, the diagrams with Sirius, and textual syntaxes, the DSL, the Xtext DSL that was just presented a while ago. And currently, out of the box, dealing with such heterogeneous models was not supported by EMF Compare at that time. For several limitations were found. So we participated in analyzing these limitations. The first one was about computing the logical model. So first, what is the logical model? When you want to compare models, actually, you need to compare a set of files, because models are saved in files, aren't they? And one model can span a lot of files. And if you want your comparisons and merge operations to be accurate and not break the references between your models, you have to take into account different files at the same time in your comparison. EMF Compare comes out of the box with an algorithm to perform that automatically. And its Git integration works well also in this regard. So EMF Compare will take care of computing the set of all the files that must be taken into account at the same time for one model comparison, instead of just performing comparison file by file. That works well, except in the case when you have heterogeneous models, both with Xtext and graphical syntaxes, which is exactly the case here. So that was the first limitation. In this regard, we have come up with a pragmatic solution that is quite easy to reuse in other contexts, that consists in introducing a model that references all the related resources that are part of one single, let's call it project, and which actually contains the list of all the files that must be dealt with together, and so that have the same life cycle and that must be compared together. So this is a very straightforward solution that's easy to implement and that guarantees that tools like EMF Compare to perform comparison will work well. So if you can click on the next slide, yeah, as a takeaway, this is a solution that's easy to implement, pragmatic, and that can be reproduced for many DSLs if you're able to maintain such a model that simply references all the files of one consistent unit. Okay, second limitation that we had to deal with was the resolution of Xtext. As you know, Xtext uses its own mechanism to deal with links between elements. In textual syntaxes, links between elements are materialized by simply using the name of that element. And when Xtext passes the source code and builds a model, it will create a reference so that you can navigate from the use of one element, here, for example, the node mass on the top right, to the declaration of this element, which is the variable declared at the bottom of the screen, variable node scalar real node mass. So this mechanism is entirely a logic mastered by Xtext, and it works in the workspace in the context of the workspace only, using numerous mechanisms, quite technical mechanisms of Xtext. But if you want to resolve a link of a file that is stored in Git, Xtext cannot help you there because it does not know anything about all the associated versions of other files in the same Git revision that you want to use. So when you want to compare your local workspace with another remote revision, including all the files of your model between what you have in your workspace and what you have in Git, Xtext is not able to resolve the links regarding the size, the side of your comparison that is the hosted in Git. So we had to come up with a solution for that. And we investigated the Xtext APIs and the mechanisms available in EMF Compare and came up with, this time, a generic mechanism that is now implemented in EMF Compare and part of the official EMF Compare release. So anybody can benefit from that, to force Xtext linking mechanism to use the right indexes and the right information to resolve the links on each side of the comparison, no matter if it's two-way or three-way. So that way we can get accurate comparisons even when dealing with Xtext models. And the good news in that collaboration that was funded by the CEA is that it benefits to the whole community because it is included as open source code in the official EMF Compare solution and is available for anybody to use, which is a great result. So third and last issue that we had to deal with was the matching of Xtext elements. When you compare models, matching elements is one of the most important first steps. Matching elements means to recognize that this element on the left of your comparison corresponds to this element on the right. It's quite straightforward when you come to think about it, but it's a very difficult step technically to achieve. And here the problem that we face is more theoretical than a problem of implementation. Textual, when you deal with graphical models or XMI models in general, you can use unique IDs to recognize objects. So if an object has been renamed, for example, you know that it's the same because even if his name is not the same, its unique ID is the same. So you can very easily match objects between each side of the comparison using this unique ID. When you deal with textual models, there is no such thing as a unique ID. Objects are identified by their name and by the scoping rules that correspond to the DSL and that are very specific to each DSL. So there is no easy generic solution to that problem. And we have been investigating with the CEA some heuristics and way to deal with these limitations so that the comparisons are as understandable by human beings as possible in the use cases that the CEA needed to address. So we came up with an ad hoc matching set of rules that are really tailored to the Modane DSL. And this is something that is not generic and would have to be re-implemented for each DSL to support the specific semantic and scoping rules of each DSL. So this is something that we are still working on to improve the results that we are currently getting in the Modane context. And we are also investigating how to make it so that EMF Compare is configurable enough for anybody to easily plug their own logic when they want to deal with textual DSLs. So that's something that will not be ready in 2 weeks' time. It's really hard work and research work. So we will keep you posted when we make progress on that topic. And I think that's all on my side regarding EMF Compare. So I will leave the microphone to Marie-Pierre and Benoît. Thank you.
So we are going to conclude. We can say that even if this new version of Modane is still under development, we can already say that Sirius gives us the opportunity to quickly achieve an Eclipse integrated development environment. This new product will avoid to switch between Magic Draw and Eclipse and to go from design to C++ development. Consequently, it will probably increase efficiency of development. For this purpose, we have used a large array of Sirius functionalities, like several types of graphical representations, properties view, navigation, and we are still attentive to new ones, like new diagram layouts, for example. So before deploying the product, we have to continue the job on collaborative work with EMF Compare, and also to improve the stability of Xtext and Sirius integration. So thank you for listening.